Hey there, how are you, Alba?
I'm good.
Excellent. How was the open hack on Thursday? I really missed it.
It was good.
Did you find that there were more people you hadn't met last time?
Well, there's some other people that came that usually don't go, not from our class per se, but other people, yes.
And there's a meetup. There's a Women in Code meetup on Saturday.
Yeah, they rescheduled it from yesterday to next Saturday.
Oh, right, it's Sunday. I've been working. Yeah.
Yeah, that one was rescheduled from yesterday to next Saturday.
Okay. That's good. Hi, Ryan.
Hello, how are you?
Doing well, thanks. How about yourself?
Moderate. Yeah, getting prepared for next week.
Great. Really thankful for this because there were times where I was just looking at it like, yeah, I got this. I just have to do this, this, and that. And then there were other times where I would forget what I had to put in and where. Right? I'm like, I know what the information is, but I don't remember how it goes together. Yeah.
Yeah, I mean, to some degree, there's an amount of memorization required here, and sort of with practice, it'll get better. I think that like I'm more than willing to sort of go through it again or sort of give you the slides to reference back to. And I think it's just one of those things where like after you do it like 50 times, it'll sort of make more sense.
Most definitely.
Postman and Curl were pretty kind of self-explanatory. So those were pretty easy to get used to. There's only a couple of things that you have to learn, like for curl, just the minus X and the minus D and minus H. So there's not much to actually memorize through that.
True.
But I know fetch has a lot more to it than
Yeah.
other stuff. So there's a lot more components to that step.
Yeah, fetch is something I really need to review on. But yeah, I couldn't remember what order to put things in for curl. And I was able to get some responses from Postman that were good, that were okay. But not enough. So, in the terminal, I was also able to get a few responses back that were correct. And then there were some where I just got stuck.
Yeah. I think what helped me with curl was there's only 3 letters. The D is for data.
Mhm.
Technically, if you're looking for the body or the data in the body and stuff like that, you will use D. The
The
X is for the get, post, and stuff like that. So
Mhm.
usually X is like the major thing, and then H is for header. So
Great.
just so I wouldn't get lost, I was like, okay, says there's a header, I'm gonna use H. They
Yep.
say body, I'm gonna use D. And you always use the X because you always gotta get a get or a post. So
Right. Yeah. And I'm like, okay, so I have that. Why isn't it working?
yeah.
Okay.
I think one part of it that's really important is like you have to like character by character get it all correct.
Mhm.
And if you don't do that, like that's going to mess you up. And the other thing too is you need to make sure that you're not in some sort of interesting terminal mode when you run it. So you have to sort of be at your root prompt with your like or with at in the shell with your prompt showing up, sort of the regular thing. I guess those are the two things I'd recommend like making sure that are correct before you start troubleshooting, I guess.
Yeah. All right. Could I share my screen, please? And I'll open up
Sure.
one of the programs. Thank you. Let's see, closed that. Where did I put postman? Mhm. Just get rid of what I don't need. This. So I know that I have to do post. I'm looking for a path. I don't even know if that first part's right, but
Yeah, so
path.
it might be worth clarifying here. What you've got in your URL field right now wouldn't be valid.
Okay,
So right now you've sort of got like a host name space a port, and that's not really a way you'd format it. If you wanted to put a custom port in there, you'd put space. At least like that's sort of like a bit of like a minutia detail, but like in general, for this module, we're not really gonna have to deal with custom ports. I'm getting at least from last week and also seeing this here too, like I've noticed you tend to want to specify ports when you do this stuff, which is not a bad idea, but it seems like it might be confusing you a little bit because it seems like there have been a few times now, at least when I've seen you do some screen sharing where like you've included a port and that's been like the main thing wrong, but everything else has looked fine.
okay,
So I might suggest like if you don't include a port, you're probably going to have more success.
all right, great.
You know what I'm saying?
Yeah, if I don't have to include it,
Yeah.
I
So
won't. It'll be one less thing to worry about.
yeah. Otherwise though, what you had there before would have been valid, but I don't know if it's exactly what you had meant. So you had question mark path equals something.
I don't
What you
know.
were sort of,
how-
oh, go ahead.
I don't know how a couple of those things got there. I just opened it up. I'm like, oh,
Okay, fair enough. Yeah.
but here at this point, I don't remember if I'm supposed to put in, what was it, text processing? Slash verb.
Oh yeah, you're talking about for the homework. Yeah. I think verbs plural maybe?
Yes,
I don't know. We'll see.
it's in plural.
Okay, cool.
It was, okay. And that's as far as I got. I knew I had to be a post. I knew I had to go to the careers and code and the path. We didn't need headers, but then I had to add a body. So I can do that here. Is everything else correct up here?
That looks great to me. I bet if you hit send, it's gonna work. Cannot post. Oh, you've
So did, she's not putting the 80 for the, channel itself, but is she putting HTTPS?
oh
back?
yeah, you probably do need to stick an HTTP in front of that. It's probably gonna be it's probably going to infer it, but it's probably be a good idea to do it either way. The other thing it looks like is I think you might have a space at the end of your well HTTP://
It's so hard for me to see it. There we go. At first,
CA in careers and code.
I cut that, didn't I? So, oh, see? Oh, it's so small. I really realized I have a hard time.
If you're having trouble seeing it, if you hit Command+, it'll make it a little bit bigger for you.
Oh, thank you. I knew there was a function and I hadn't remembered it. Oh, goodness.
And
gracious.
Command might also go the other direction if you want to
Yeah.
make it smaller. if you go to the very end of that URL, I think you might have a space at the very end. Yeah, so the way I knew that is if you go down to the body that you got back, that HTML,
Mhm.
it said, and scroll down to like line like 5 or 6 in it, in the response body. Maybe like 8 or 9. I don't remember which, yeah, line 10, that's what it is. It says, cannot post / text processing / verbs %20. And we didn't talk about this, but there's you can't put every character possible in a URL.
Okay.
And if you want to put characters that are sort of non-URL safe characters in a URL, there's a special way you encode them, special way you sort of tell them to the computer so that it can transmit it with those unsafe characters. And it turns out space is one of those unsafe characters. And the way it transmits it is by using %20. I'm realizing this is something I need to add to the next cohort because I totally skipped over this as a thing, but I'll touch on it maybe next week in class just to review it. But this is I wanted to mention that's how I knew there was a space at the end because I saw that down there.
Thank you for mentioning that. And so that worked. Awesome. I'm gonna do it. I'll minimize you guys so that it doesn't take a screenshot of you. Then I can send that for homework. And then I wanted to do one in the terminal if I could, please.
Yeah.
Okay, great, thank you.
Also, if you want to make the text bigger in the terminal, you can do the same thing, Command plus, Command minus.
Of course, I didn't remember my glasses today. Oops.
Oh, you did that on your desktop instead, but I didn't know you could do that.
That's cool, though. All right. So now for curl, I don't remember what I'm supposed to put here. I was trying curl, careers in code. ML. Do I have to worry about the port here, or can I leave it out?
So it might be helpful if you open up the presentation from, I think it was last Wednesday. I think it was Wednesday. And we can sort of take a look at one of the slides, which should have this information in
It's
it.
on Slack.
Mm-hmm.
It's on Slack, on the careers and code C4.
Thanks, that'll be a faster way to get to it.
I think I just pasted it in the chat, and that's the slide I think you want as well. Oh, wait, no, that's the wrong slide. Go to 115, I think it is. Too many windows.
Yeah, messes me up. Okay.
Kept the slide in the URL. The one right below 114.
Okay. All right, so I'm forgetting the order of things again. So if I were to do this on my own, I'd be looking at it and I'd be like, okay, so here I am. I have to do, wait for it. X post. You don't have to put the H, but I do need to put the path,
The body.
the body first.
The order shouldn't actually matter, but you can, yeah, you can do the body next there.
Does this have to be in quotes?
Yeah, you probably want to put it in quotes.
And then can I just skip to this part?
So if you take a look on the example, you'll see that it's got a URL there. It doesn't have the host name and the path as separate places. So I'm looking at that example.com/test.
Right. So I don't know what that relates to. So I've got the D, which is the optional body.
Mhm.
And then is this where, I guess, where do I ask for? Am I just repeating the careers in code? .ml?
You want the same URL you put into Postman, you want to use in curl. So where it said like http://careersencode.ml/text processing/verbs, that whole thing spelled out.
And does that need to be here or at the end? That's where I can't keep. So
I would say probably if you want to follow the exact format on the slide at the end. In practice, though, it probably doesn't matter. But do it at the end. I think that's going to make it more straightforward for you.
Okay, so I could put the body here and the path.
Put the whole URL at the end.
Does it need a slash before it? No, okay.
So keep in mind the URL is the protocol, the host name, and the path all put together as one thing.
So after cookies, before the backslash,
Mhm.
put your URL.
Okay. And then the path.
Mhm. And you can also get rid of that careersencode.ml at the beginning. You don't really need that.
Yeah, okay.
If you arrow key over there, it's probably the easiest way to go over there and delete it.
Okay.
Unfortunately, all the sort of text, like clicking around stuff with your cursor isn't going to work in the terminal.
Yeah, it's messed me up a few times trying it. But I do have to keep curl there, yes?
Yep, you have to keep curl there. So curl's the program you're running. So that's got to be at the very beginning.
Okay, I'm gonna screenshot this.
But if you look at what was typed there and what's in that slide, the formats correlate, like they match pretty closely. So I would say if you try to just copy what's on that slide directly in your terminal, substituting the pieces as you need to, you should be able to get this.
You sound like a robot.
Did my
I-
internet just go out there for a second?
Yeah, I missed what you said.
Ah, gosh. I should say just like context, I've been having some internet problems this past week, and I'm kind of shocked that I didn't have problems during Careers in Code normally. So I'm glad to hear this is the first time it's happened, but I'm sorry.
So I've got the curl X, post D body. And skipping the header.
Mhm.
And then the URL.
Yeah.
Pass.
Yeah. So what I had said before there is if you were to copy what's on that slide piece by piece into the terminal, substituting the pieces you need to substitute, you should be able to get what's there in the terminal on your own just by going section by section.
Okay, I guess that's good. And I keep looking at it and I'm like, wait, where's the path? Where do I put it? Because I didn't realize that this was the path.
Yeah, I think something worth bringing up is that when you're using tools like Postman and curl and also fetch as well, you're really speaking more in URLs than paths. And a URL is like a combination of the path, the host name, the protocol, and some other things that are optional, but those are the three most important parts. So I wanted to talk about paths because it's important to understand that that's part of like what's being sent in the request. But going forward, when you're sort of telling these higher level tools what to send, you're going to combine all that stuff together into one thing, and it's going to kind of split it apart and to know where to connect, and then sort of part of what to send in the body, or sorry, in the request.
Okay. So where's my cursor here?
The very beginning.
Right.
Oh,
I want to run this. I thought dream would be a verb.
I would think it would be too. So I'll say like my natural language processing is maybe not the best. I just copied the first thing I found online. Try something with a more obvious verb, and that might work.
Okay. I'll bow out now so that someone else can go. Thank you very much.
Yeah, no problem. One thing I think I might do if we have some time near the end of this, it seems like folks aren't super familiar with the terminal, and I could probably do a quick little like, here's how to navigate around the terminal quickly and it not to be a total pain lesson. That would be like 5-10 minutes.
Yeah, just did a little bit in DevOps, but I would love a review and some more information.
For sure. Oh, are these normally recorded?
It says it's recording.
Oh, okay, cool.
When I went in.
Sounds good.
Do you have any questions, Karen?
I'm just trying to play catch up.
I just asked because I don't have any questions right now, so if you need help with anything, go ahead and ask.
Oh, no worries, no worries. I'm just, no, just playing catch up. Thank
Cool. Yeah, I mean, I'm here if you need anything, but if nobody else has anything, I see Snyder, you've joined as well. So I don't know if you have anything you want to chat about, but otherwise I'll do that quick little terminal lesson just to get that out of the way. But I don't want to do that if folks have questions. Okay. You're good? Okay, cool. Let me do that then. That'll be a fun one. So I should say maybe before I do this that I'm like, I've sort of gone down the terminal rabbit hole, a proverbial rabbit hole, as it were, and it's sort of a very key part of my workflow. So I guess like, and I'll say like why that I've done that too, because I think that might provide some value. Like for me, the terminal is a really efficient way that I can interact with the computer. Oh gosh, my internet connection's unstable again. Okay, well, we're gonna keep going and hopefully we'll see what happens. But it's a really efficient way for me to interact with the computer. And I really like that because it's sort of, to me, when I work, the bottleneck for interacting with the computer for me is like my fingers typing. Like my brain can move at a certain speed and the computer can generally match that speed, but I have to sort of take what's up here and put it into what's there. And like that interface, my fingers is like slow. So I sort of have this like bottleneck that sort of that information has to pass through. And I've found that the fastest way or the way I can make that bottleneck the biggest is by using something where I can sort of keep my fingers on the keyboard as much as possible. And I can just start like type and like as quickly as possible transmit information from me to the computer. And at least for my workflow, that's been really important. So like that maybe gives you some background of like why people like generally like terminals, because when you're not having to like do all this sort of like clicking around sort of thing, like you're able to sort of have a very high bandwidth sort of like way to talk to the computer directly, and that's often very nice. But it comes with its own caveats, and one of them is it's not very user friendly. So let's talk a little bit about how to navigate around it. I'm going to make myself a new terminal window here and share my screen. Okay. Cool. So here's my terminal. and this is going to be a review for anyone who I was chatting with at OpenHack. So Schneider, I think you've heard most of this already. But in general, if I'm typing a command, there's a number of little keyboard shortcuts I can use to very quickly move around that line. So I'm going to just type out like, hello world, this is a test, something with some words in it. So first of all, I can arrow key around. And that's something that like, I think probably most of you have sort of figured out, and that's kind of typical to what you'd expect in other sort of text editing situations. One that's a bit unique to the terminal, though, is if you press, I believe, Control A, it'll go to the beginning of the line, and Control E, it'll go to the end of the line. And that's pretty nice, because just with that alone, it means instead of having to arrow key all the way to the beginning to make a modification, you can jump to the beginning and arrow key over to what you want. And that's often like you can pick sort of the side to go from, because that's whichever one's going to be faster. So that's kind of nice. Another thing I tend to do pretty often is if I want to get rid of like text by words. So let's say I want to get rid of like, this is a test and I just want to have hello world there. What people might do is they might hit like hold down backspace and do that whole thing. But that's kind of slow, especially if the lines. So what I actually prefer to do is if you hit Control W, it'll get rid of the text by word. And I find that really helpful to sort of like get rid of a bunch of text to go back to where I want, sort of to keep typing from there. Another one here, if I hit Control U, it'll get rid of everything on my line. And if I hit Control Y, it'll bring it back again. So where I find this helpful is if I've got a big long command I've typed out and I'm like, oh no, I need to run another command before I run this command. I can type Control U, go like other command, and then Control Y and bring it back. Those are the things oh, actually there's one more too, but the one more is often, I think I mentioned this in class, but often you need to clear your terminal. And there's a couple ways you can do that. One of them is you can type clear. The other one you can type Control L. So if I go like Control L, it'll also clear. I don't use the Control L one because it's just super, super fast. But like all those options I just told you, those are sort of the most commonly used in my toolbox, like terminal navigation commands. And I would say out of all those, the ones I think that would be most helpful for you to put to memory are Control A and Control E to go to the beginning and end. I'll say I use those, and I guess Control L probably the most out of all of those. Oh, and actually one more while I'm here. This is a Mac specific one. But if I want to go by word, like sort of arrow key over by word, and I hold down Option, I can do that. So I can sort of like go over like 3 words, make a change over here, and then go back over to the end or something. That's another one that's good to know. Yeah. I'm trying to think if there's anything else I do pretty often. I think those are all the ones I use pretty often.
Quick question. How do you want us to submit the homework again?
Oh yeah. Probably the easiest way is to take a screenshot of Postman and a screenshot of curl, and just include it up in the whatever it's called, Canvas assignment.
Gotcha.
Yeah.
I don't know if that part was fixed, but whenever I go on Canvas, not even the submit is up. It's just saying that it's not uploaded at all.
Huh. So I'll say that I checked with Max at OpenHack, and he told me that the assignment is something everyone can see. So just to clarify, can you see the assignment?
Nope,
He said
I can't
that
see
there was
anything.
He said that it was not that you didn't post it. It has something to do with the module itself. He was calling
Oh.
somebody to fix it, but he wasn't able to get in touch with the person. So it still is not showing up for us.
Okay, so I'm
Okay.
not the only one.
So it shows published in yours, but if you go to ours, the assignment says that there's something wrong with the module.
Okay. I freaking hate all these learning management systems. None of them are straightforward. Okay.
He said he knows what to do to fix it. He was just trying to get in touch with somebody while he was there, and he wasn't able to get in touch with the person.
when you say
While
some
we
windows
were
had,
when we were in open hack. He was calling
okay,
somebody, he said he knew what was wrong, but what it's saying is unpublished module. You publish the assignment, but they haven't
oh, I
published the
see.
module to our Canvas.
Yeah, Max mentioned this to me, and I thought he told me how to fix it. And then I asked him if he could fix it, I think, because I couldn't figure it out.
Yeah, that's why he was calling somebody, but he wasn't able to get in touch with the person. I'm not exactly sure if he forgot, and maybe we should remind him, but
Okay, let me do this. I'll send Max a message after this. Like, I can noodle around in here, but it sounds like Max just knows what to do. I posted the assignment though in Slack, so you should have like the text content of it. So I'm assuming like it wouldn't be that hard to do it and then upload the screenshots once Max or I can figure this out. I know it's kind of bad to say, but
screenshots, I was just waiting for you guys to post a thing just to put the
okay,
notes in.
cool. I'll reach out to Max and figure it out. I'm sorry that I didn't have this ready to go for this weekend though.
All good, Ryan.
Cool. Sweet. Anybody have any other questions? Well, cool. So I guess if there's no questions, got two options here. Option one, we can just be done early, or option two, I can talk a little bit more about terminal stuff. Because it sounds like I've had a few folks come up to me and ask me, like, I want to know more about this thing. So
Minutes.
okay.
Be awesome.
I'll do that then. Let me send them a message to Max though, just to be hi. Have okay. Cool. Oh, Brandon joined. Hello.
Hello.
Are you just joining to listen in, or do you have any questions in particular?
Oh, not at the moment.
Cool. Okay. So I was we went through some stuff just here, but I'm going to I mentioned I was probably going to talk a little bit more about the terminal because some folks had some questions about it. So I'm probably just going to kind of do a little pontificating here, and anyone can interrupt me when they have questions, or they are just like, I'm tired of this, Ryan. We can be done now. Cool. So Max and I think Nathan both had mentioned to me that neither of you had, or none of you have done all that much with the terminal. Like you did a little bit in the DevOps module, I think Max said, and you did some stuff with Node. But that was about it, right?
Yeah, and we did some, well, yeah, the no stuff with the JavaScript and the integrated terminal, but
Cool.
nothing too crazy.
Okay. So you haven't really used the terminal for like what its primary purposes, which is a little bit of a shame. Like you've sort of done a lot of ancillary things. So the terminal, the thing that's most important in the terminal and sort of where it probably gets the most use from me, I will say, is like file system management. So in general, in the terminal, like it's sort of a more primitive way to interact with a computer. And if you're interacting with a computer, one of the most important parts of the computer, especially in a Unix system like a Mac or on Linux, is the file system. So the file system, which this might be a review for you folks, but I'm going to maybe say this and hopefully clarify it for some people. But the file system on Unix is very different. So Unix being Mac and Linux is very different from how it works on Windows. And I suspect probably most of you are familiar with like the way it's historically worked in Windows. So in Windows, you have things called like letter drives. You have like an A drive, a B drive, a C drive, that whole thing. And what you do is you sort of take like hard drives and you mount them as like letter drives. So often like you have like your C drive is like the root drive in the system. And you can do things like go to like C program files, that whole shenanigan thing. Yeah, that. I don't use Windows all that much, and I'm generally not a big fan of it. So I'm going to maybe speak poorly of Windows, and I apologize in advance. But the way the way Unix works in Mac and Linux is very different. In Unix, you don't have multiple drives. You have one file system, like one unified file system. Also, I should mention in Unix, you use forward slashes, not backslashes. You use backslashes in Windows for file paths. Cool. See you, Jennifer. In general, the biggest difference though with the file system is that there's one versus with Windows you have like lots of them. And why that's important is in Windows, when you want to add a new thing, what you do is you make a new letter entry. In Unix, what you do when you want to add a new thing is you mount it at a position in your file system. So like by default in Unix systems, you have a file system entry slash, and then slash it is empty. And then what you do is you can mount a thing in slash. So let's say I want to take my hard drive, my local system like SSD or hard drive, and I want to mount that at slash. So I mount that at slash. And now if I look at everything in slash, I have data in there. Let's say I want to I plug in like a flash drive or like put in a CD or whatever, however I want to get my other file system or my other sort of like memory device. And I want to now access that. In Windows, you get another letter drive. In Unix, what you do is you mount that to a location in your root file system, sort of like overloading like a directory. So let's say in your file system, your root file system, you have like a directory called test. And in that directory, you have some data in it. Maybe inside of the test directory, you have like a file called hello. You now plug in your flash drive, and you take your flash drive and you mount it at /test. What would happen is everything on your flash drive would now show up at /test instead of the data on your original file system. So you can think of it sort of as like you're sort of like overriding that directory with everything in the flash drive or whatever other thing you plugged in. And why this is kind of cool, like it has its pros and cons, but why I think it's kind of cool is it means that you can sort of like detect everything can be managed under one big file system space. And you don't have to think about like distinctly different drives. And it also means that if you unplug a thing and plug it back in, the mount point, sort of that directory, you can set up to always be the same. So you can sort of do some interesting like automation-y things around it. And there's a lot of other details probably that I'm missing out here, but sort of just like the internet explanation with the TCP stuff and all that, like that's probably the high level understanding of probably what you need to know on a day-to-day basis. But what that means is you have this file system, cool. How do you navigate it? Like this is sort of where applications like Finder on a Mac come in. And that works, but Finder gives you like a very sort of high level view. It makes it kind of hard to actually see like what's actually going on the file system. And you can do it. Like you can sort of, if you know what you're doing, you can make it work. But the terminal will give you all that. So for that, we're going to talk a little bit about one of the most important things in a terminal, which is how you navigate around the file system. And usually when people get introduced to the terminal, this is the first thing they learn. So you all have kind of gotten it a bit in reverse order. Like you sort of learned like some of the weird side effect, like unrelated things. And now we're going to talk about the main thing here. So we're going to talk about some commands you can run on the terminal that are sort of some of the most important key commands.
I don't want to interrupt you too much.
Yeah.
He did post the assignment. There's just we don't have a way of actually submitting the screenshots in the assignment.
Oh, okay. Okay. let me take a look at that now, because I want to make sure that like that's set up right, and I want to do that with people around here. And I'll get back to my riveting terminal and file system explanation. So I'm gonna go. I thought I set like it was submittable. Yeah, I have file uploads checked here.
This is what I
Um,
get in mine. Hold on. Let me share my screen.
Yeah.
So this is all I get. Week 11 quiz instruction,
Oh,
and that's it. It just
If you-
summarizes. It doesn't say anything else.
if you go to assignments and then go under week 11 homework, I think that's what you want.
Was there supposed to be a quiz too?
Oh no, I don't think I didn't know I was supposed to do that. Maybe I should have set that up. Good to know for next week. Okay.
All right, thank you.
Yep. Cool. Yeah, I think if you hit start assignment, that should work.
Okay.
Sweet. Also, if someone else could go in and check that too, just to make sure, I want to get a couple data points because I'm tired of having this like it's showing up for some people, not showing up for other people, not quite working. Like, I don't know if it's me or you or what's like, I don't know. I'd like to get this resolved. Cool. Okay, back to the terminal. So the most important command, I think, to know is called PWD to start with. Run PWD and hit enter. And this stands for present working directory. So there's a key concept in the terminal, and you might have noticed it if you look at on your little prompt here. You'll see like something that looks kind of like a path. It might be a tilde, it might be something else. But what this is your PWD, or present working directory. And it's this concept of like the current directory you're in the terminal. And this is really important because when you type things in the terminal, this is sort of the directory that the command you're running is going to run in. For everything you've done so far, there hasn't really been a reason to care about this all that much. Like, you haven't needed to use any files when you're running a command. I guess maybe with Node you maybe did, but it probably started its present working directory in VS Code's like directory or something, so you didn't have to think about it there maybe. But this is like a really important concept, because if I want to do a thing with a file, like all local file path direct like that I'm going to type out are going to sort of start in this directory. Now, you want to be able to change this directory, which is sort of an important thing. And we're going to talk about that in a second. But before we talk about that, we need to talk about how you can sort of see, like this is sort of like the directory you're in, but you also need to be able to see kind of like what that directory looks like. Think of this as sort of the file path at the top of the Finder window. And this command we're about to type is sort of like the contents of the Finder window. And this command we're going to type next is called ls. You also notice all these commands are short, and they're short because you type them a lot, and because they've been around for like 30 or 40 years and have not changed. So like it's baked into everyone's muscle memory, and this is just sort of how it is. So ls stands for list, and this will sort of show you all files and directories in your present working directory. So you can see I'm currently in users Ryan, and in this directory I have the applications directory, the queries and code directory, the desktop directory, and all these other different directories here. And files, so like foo.html, mocksensor.go, all these different things. Okay, the last really important command we're going to talk about is cd, and cd allows you to change your directory. So you can cd, so both these commands don't take any parameters, it's just the command, well, they do, but we haven't talked about them yet. All their parameters are optional, I should say. You can run them without parameters. cd has a required parameter though, and that's the directory you want to change into. So cd stands for change directory. So let's say I want to go into my desktop. Like I'm in users Ryan, and I want to go to users Ryan desktop. The way I can do that is I can type cd desktop and hit enter. And you'll notice that when I do that, this little path in my prompt changes, and that's very important. And this is really nice because it tells you your directory you're currently in before you start running things. So now if I run ls, it's now going to list every file on my desktop, which because I don't ever clean up my desktop is going to be very, very long and large. But it lists all the stuff. And that's very nice. Let's say I now want to like go into another thing. I've got this, looks like I've got this like Vectorworks environment directory. Let's go into that. So I can type cd Vectorworks environment. And you see now it updated again. You can do ls here. I got a bunch of stuff in there. And I can sort of keep doing this and sort of go directory by directory. And what I'm sort of recreating here is a sort of workflow in an application like Finder, where you have this window and you have a bunch of files and directories, and you sort of double click on a directory and you go into that directory and you're looking around and you're like, okay, I want to go into this one. You double click, you go in, and you're sort of navigating your way down, tunneling your way down through each directory level. It's sort of what I'm doing here, but this is sort of the way you'd accomplish that in a terminal. One last thing that you should know if you're going to do this is there's another command that's really important. How do you get like back? So like I was in desktop and I wanted to go into Vectorworks environment. How do I like get back to desktop? And the way you do that is a special version of cd, cd ... And then I'll go back a directory. And that's really the minimum of what you need to know to navigate around in the terminal and sort of to like go into directories, come out of directories, and sort of to get yourself into a directory you need to do in order to run a thing.
I was just gonna ask, how do you like pull from there once you're in there? Like, can you access files from?
Yeah, totally. So let me go back into Vectorworks environment. So let's say I want to open up this foo.py file and take a look at it. So I guess before I say this, I should say like that's a bookend on sort of like that section is like navigating around the terminal, very basic introduction with file system and all that sort of stuff. Now we're moving on to like slightly more advanced stuff, but still quite foundational. There's another command you can run, and one of the commands I think it's also pretty important that will print out a file. And this command is called cat, C-A-T. This is another one of those commands that's been around for like 30, 40 years and just like is baked into everyone's like inner psyche or whatever. But if I type cat and the name of a file, it'll print that out. So if I type cat foo.py, that'll print out the whole file here. And it's kind of long. It's some Python code, but the contents of the file doesn't really matter. It's just I printed it out. And what you'll notice is if I go back here and go back to my desktop and now run this cat again, that's not going to work because I'm not in this directory anymore. Like there's no foo.py in the desktop. So does that make sense?
Yeah. I thought you were asking a question. I was gonna say, well, yeah, you're not in the file, you're in the desktop. But yeah, like I feel like once you can work around the terminal shortcomings, it's not that bad.
Yes, I would put my own spin on that and say it's not just not that bad. It's actually way faster and more efficient, in my opinion. Like, if you were to, like, I feel like I could race somebody and be like, okay, I'm going to ask you to sort of get to this directory and then like open up this file and like make some edits to it. And that's a task you could totally do. You could sort of click on it and you open up the Finder, go into a directory, go into it, find that file, select it, open it up, and then like look through that file, make your edits and save it. I feel like I could probably do that in the terminal with the level of knowledge I have in like half the time. And that's not, or maybe less. And that's just because like what it's optimized around is a lot of what sort of system administrators and in many cases software developers need to do. So
Right.
it's one of those things where like at the point you all are at now, it's probably going to be kind of a pain, but I'm bringing it up because it touches in a lot of different places. And at some point in the future, you'll probably like get more familiar with it to the point where it actually will be quite a bit faster than sort of the workflow you're using now. And that's where things, at least in my opinion, start to get really exciting.
I'm looking forward to it then.
Fair enough. Cool. Well, if nobody else has any other questions, I'm just going to keep talking for the next 10 minutes or until we're done. I think it's supposed to be an hour long. So you might also be wondering what's up with this like tilde thing here, because like when I open up my terminal fresh, like open up a new, well, actually I can just go cd ... sort of at this here, and then I ran pwd and it said like this. These are different. What was going on there? Maybe you were thinking that. Hopefully you were thinking that. But what's going on there is there's another concept on Unix systems, so Mac and Linux, it sort of differs from Windows. Well, I guess it's kind of similar on Windows, but on Mac and Linux, you have this concept of what's called a home folder. And you can think of your home folder as sort of like the directory that your user sort of writes all of its data files to. So let's say you have like you want to make like a text document and do a bunch of sort of processing. Big long tip, you would into your home folder and you would make the file in some subdirectory of your home folder somewhere down that somewhere. So you put that in your home folder, and then that's sort of where that file would live. So because that's sort of where a lot of your like user data lives, that's usually the default directory that a terminal will start in. And it's such a common directory that it's got a little shortcut, the tilde. So I can actually type, if I'm like in my desktop, I could type cd tilde and it'll go back to my home directory. I can actually, in fact, type any sort of path I want here. It can be a full path, like starting at the very beginning of my file system, or it could be a partial path. And that partial path would sort of like add it onto my PWD. So sort of like if I did like cd desktop vectorworks environment, that would work. I could sort of go into both of those. Similarly, I can do cd .. and I'll go back too. Or there's a bunch of these little shortcuts, and it turns out ... is actually kind of in a similar category as tilde, where it's like a shortcut. Now, going to your home directory is in fact so common that if you run cd on its own, like with no arguments, it'll actually go to your home folder. It's its default behavior. You don't do that. Well, I guess it happens, but it's not the most common use of it. Like usually you want to give it a parameter, but you can sort of not give it a parameter and it'll go back to your home folder. There's also though, like we're still in the home folder. There's stuff like going back up from the home folder too. So if I'm in my home folder and I run cd ... let's see what's going to happen here. I go to users. So users Ryan, I'm in users. And now if I do pwd, it confirms I'm in users. Okay, so I just like, this is like a directory that usually you don't really see. Like you're in like the Finder, you sort of kind of start in like where all your home folder stuff kind of is. And you see that directory, but you don't really see like anything outside of that. So let's take a look at this thing. Let's see what's in here. Okay, so there's two directories. There's this thing called shared and this thing called Ryan. And we were just in Ryan, so that kind of makes sense. What's in shared?
Is it because you have another account on your laptop?
I don't actually have another account on my laptop. I'll be honest, I don't actually know why shared is here. It might be a Mac thing, but it looks like there's some stuff in shared. Oh, I should also mention, you can give a path to ls, and it will sort of like cd in that path and run ls kind of behind the scenes. So let me do that using the concepts we've learned so far. So if I did like shared ls. So there's some stuff in here. Yeah, I don't know what that is. But generally, if I had multiple user accounts, you're right, I would have multiple directories in here. But let's go up one more. Let's sort of keep working our way up and see what's up here. Okay, we're at slash, we're at the root. If I did cd dot dot from here, it's not gonna do anything. I'm at the root. Going back up is like, it's like the end. It's like where it all starts. Let's take a look at this and see what's in here. Okay, this is where things start to get exciting. So anyone who's like familiar with Unix systems, when they see directories like this, they know they're in the root. And these directories are sort of very standard directories. So things like bin, temp, tmp, user, usr, var, var, opt, opt, home, etc. These are all and private on Macs, and sbin's another standard one, but these are all very sort of standard Unix directories. And what do these all do? Well, that's kind of a topic for another day, but we'll talk about a few of them real quick because some of them are kind of helpful. These are also like all the stuff I'm talking about right now. This has not changed in like 30 or 40 years. My mom in like the 80s worked on computers sort of like in like an engineering here and there. And when I was originally learning this stuff, I mentioned it to her and she was like, oh yeah, I know all this stuff from like back when she was doing it. And like, it didn't change. Like it's just how it's been. So like, I guess what I'm trying to say is this stuff has been static for a while. And like a lot of the reasons why things work are sort of like weird historical reasons that might relate to things like tape drives and stuff like stuff that has not been for a very long time. And sort of the consequences of that decision has sort of been handed down. So I'm putting that in here because like there are things you might be like, why does it work this way? And you look it up and the answer is like, wow, that's a really archaic reason. And like, yeah, that is. And it's just sort of how it is. And it hasn't changed. And it hasn't broken. So like, it's sort of the it ain't broke, don't fix it philosophy, I guess.
Yeah, I was just gonna ask, like you said, a lot of those stuff were like from like 20, 40, 30 years ago. So those are still relevant to us today as well. Like they all still function well, I guess.
Yeah, it's one of those things where like decisions were made back then and people got used to how it worked. And sort of like so much stuff is built on top of how that stuff works, where to change it now would be so hard and complex, where it's just like not worth the trade-off. At least that's my understanding as to why it is.
Yeah, no, that makes sense.
Yeah, but it does leave you in a bit of a weird situation, where like you're sort of having to sometimes make decisions based on decisions that were made all this time ago. But anyway, let's talk about what a few of these directories are. So the first one I can talk about is var. And this is a directory that is like so remember how I mentioned how like different directories in the file system are sort of like can be mounted on different like media. Like so like you might sort of have one thing on like one hard drive, another thing on another hard drive, so on and so forth. Well, it used to be that root file systems were really small and were also read-only. Like that was typically how it was done. You'd have these old big Unix mainframes, these like, at the time, very large computers with like less than a megabyte of RAM and like some like kilohertz or like very small number of megahertz CPU. And you'd have to have all these people who would like have their super like small little like thin client things at their desk and they'd like connect to the mainframe. And the mainframe would be running some Unix that would have a root file system and it would be on its like some number of megabytes, probably hard drive. And what you would have in order to make that work is you would have like you have all these users sort of connecting to the system in a shared fashion, sort of all sharing that those resources to sort of do whatever they needed to do. And if you're in a system like that, and sort of like a workflow like that, it kind of makes sense to make a lot of the data that everyone has access to read-only, because then you can't have some careless user go in and like accidentally like mess something up for everyone on the mainframe. So generally, historically, the root file system has been read-only. var is the location where all the things that are like need to be written to historically would live in Unix. So let's go into var and take a look around here. I should say before I run ls here, like this is going to have a lot of stuff in it. And also on Macs, there's sort of some deviations from Linux, which is a little bit more like historically how it would be done. On Macs, Apple's done some like made some changes and sort of made some adjustments based on how they want to do things. But historically, like you'd have stuff like for example, log. Var log is where all your system logs live. So logs being like effectively all the things like your system does a console.log if you were in sort of the JavaScript ecosystem across your whole system. So there's all these files that are just like log files and it keeps track here. And they sort of get rotated out. So like old log files will eventually get thrown away and new log files will get created. And this is like if you're troubleshooting your system and you want to just see like all the logs from the system, you can go into var log and take a look at them. This is like an example, and because you're writing logs, like you can't put that in like a read-only file system. What else is in here? Also, like if you can't tell, I don't have any. I'm just talking, so like I'm just headed down a path. If you have questions or want me to go in a certain direction, let me know. Or
I got a question. That's
Yeah.
it's a pretty rabbit hole-y question. So Linux, Unix, and the kernel. I know the Linux and Unix, they like run in the kernel, right?
Linux is a kernel. Let me explain what a kernel is sort of just generally to everybody. So a kernel is sort of a piece of software on a computer that generally manages, I guess I would say, it's perhaps the internet describe it. What is a kernel? Sorry, I'll get to your question, but I just want to make sure everyone's sort of going from the same footing here.
No, you're good.
The
I don't
heart-
even know what a kernel is neither, honestly, like completely.
The heart, well, and I get all these pictures of corn, which is amazing. But the kernel is the heart of the operating system and controls all the important functions of hardware. Yeah, that makes sense. So it sort of tends to be the bridge between the software that users tend to write and the underlying control of the hardware. So an example is like, let's say you have, let's say you've got like a CD drive. This is the only example that's coming to mind to me right now, but it's probably not a great one for like modern computers. So you've got a CD drive and you want to eject that CD drive. So you have a program that does that, and you can click a button in the program to make that happen. But like that program doesn't want to have to be built to work with like 20 different models of CD drives. It's like such a pain. Like you'd have to sort of do the thing where you're like, figure out what CD drive you have. And then for like the first CD drive, you like give it this instruction. For the next CD drive, you do it like this other way. It's a little different because they've like built them differently. And this third way, you do it like a different way. Like it would just be easier if you could just be like, make a thing called a CD drive and like tell it to eject itself or something like that. Like to you click that button, you want it to eject. You just want to say like, eject yourself CD drive. And you don't really want to care like what the model of the CD drive is or anything like that. So that's kind of what a kernel fundamentally, one of the important things for her kernel is it will sort of handle that device level of abstraction. So it'll give you some types of devices, and then it's up to someone to make what are called drivers. You may have heard this term before, especially in like a Windows world. And what a driver does is it sort of implements that interface the kernel provides, and then talks to the hardware to tell it how to do that thing. So like a driver for a CD drive might have like things in it where like you might have like a function in that driver that's like eject. And what the kernel will do is it'll sort of take all the calls you make to it, and it will sort of send those to the driver and basically be like, someone told me to eject yourself, CD drive, so go eject yourself. And the CD drive, the CD driver will be like, okay, cool, and it'll eject. That's like one thing the kernel does. Another thing the kernel does is process management. So like a computer by default, like raw computing, like you have a CPU that can run instructions over and over and over. But you can't like run multiple things on the computer. Like you can run like one thing at a time. So the kernel, like when you start up the computer, runs. And what it does, it sort of like allocates time to different processes. So if you have like 5 processes running, it'll run one process for a fifth of the time, the next process for the next fifth of the time, and the third process for the third fifth, and so on and so forth, and sort of keep giving each process some time to sort of like, so everyone can sort of work collaboratively, and all at the same time. And that's like kind of an oversimplification. There's a lot that goes into process management, and you have things like allocation of cycles more to certain things that need more load and all that. But conceptually, that's sort of one thing that it's doing. But you asked, like, what's sort of the, Schneider, you're maybe gonna have to repeat your original question because I got a little bit sidetracked, but I think you would ask.
No,
what-
I think I was confused anyway because I thought that Linux and Unix ran in the kernel. I didn't know that they were the kernel itself. So that question was
okay.
worded wrong anyways.
Okay, so I guess like Unix is sort of a philosophy around building, I guess I would say kernels, the sort of like the sort of ways that they work and the things they expose to upper level software running on the computer. An alternative approach is like the Windows or the DOS approach. Another alternative approach, like this maybe won't hit any bells for anybody, but like Solaris is like, or like BSD. Like these are all sort of different ways, approaches you can go about like building software that runs at that low of a level. And what they're going to provide is sort of the software that's running at a higher level, things like the terminal, like applications running on your computer, like CD, LS, all that sort of stuff. Those are going to be different in each of those implementations. It turns out that a lot, like there's generally been a lot of standardization over the past like 30, 40 years, and Unix is kind of one, like BSD, Solaris, Linux, there's other ones too. These are all like flavors of Unix, so sort of like they implement much closely similar like interfaces. Windows is sort of like the odd one out. It's like very different, and it has sort of dominated in its own sort of sphere. So you have these sort of two competitors, but like outside of sort of the couple niches that Windows seems to have won in, Unix has pretty much won. And it's just sort of like which flavor of Unix you use really depends on a few different like things. But generally within Unix, like the ones that have won have been Linux and Mac. Linux has sort of won for like server and data center uses, and a little bit in like the desktop sphere, but mostly like server and data center. Macs have really won for like creative use cases, and also just like they've been kind of gaining market share just generally. And then Windows has been like businessy stuff. I mean, you all kind of know this, I think, but like for that, like I've historically avoided Windows for a lot of reasons, but like generally, as a software developer, especially a web developer, unless you end up going down sort of more the Microsoft path, you're probably going to be using a lot of a Unix stuff. Does that make sense? Probably way more detail than you asked for, but
No, more than enough actually. It also helps to know that that the kernel is a software thing, not a hardware thing.
yeah,
Yeah.
for sure.
Yeah.
And I should also say it's possible to have a computer without a kernel. Like if you've ever used an Arduino, or if anyone knows what that is, it's like a little board where you can sort of like program it from your computer and it can run software on the board. That doesn't have a kernel. The code you're running is running like straight on the CPU there.
So
And-
bare metal coding, as they say.
Yeah, bare metal is sort of the phrase. And why that's kind of nice is I mentioned like the kernel, and it gives you all these benefits, but there's some downsides. Like all those benefits take processing power and take time. If you have a system that's super low power and you're like, I need to crank out every possible inch of or like liter of performance from my CPU or whatever. I'm mixing metaphors so much here, but hopefully that makes sense. Like you maybe don't want to use a kernel, but it means that you're not going to get all the benefits it provides. On Arduino, or like microcontrollers like that, embedded systems, you often have such little processing power, and what you're trying to do is so straightforward, where something in the kernel is really just not really needed. But yeah, I mean, at Density where I work, we have embedded devices that are out there in the world that all run Linux. So these days it's becoming more common because through like Moore's law and sort of CPUs becoming more powerful, you can sort of afford to sacrifice those cycles to have a kernel effectively. Cool.
I'm looking into the Arduinos. That looks fun.
It is fun, indeed. Let's what other directories do we have here? I think bin is another really important one, and that'll bring me down a path here. So on historically on Unix, bin is where all of your applications live. So what do I mean by an application? I mean like a command. So something like you ran node before, you run that command. Behind the scenes, that's actually running a program somewhere. Historically, that lives in /bin. So if we go into /bin here and do ls, you're going to see there's a bunch of commands in here, like ls is in there. CP, we didn't talk about that, cat's in there. What other commands that we talked about that might be in here? Looks like those might be the only two we've talked about. But you'll see, like, wait a second, you just told me like node would be in there, but you don't see node in that list. What's going on, Ryan? Are you lying to me? And this is another one of those things where I only told you half the truth, which is that yes, all your commands are in here, but there's other places where the commands can live too. So, but before we do that, let me just sort of prove to you that these commands do live here. Let me actually run let me run ls. So if I'm in a current directory, like a directory, and I want to run an executable in that directory, the way I can do that is I can try // in the name of the executable. So if I run // it's going to run the ls program in this directory. And if I run that, you'll see it lists out everything in the directory. Hey, isn't that cool? We talked about echo a few days ago in the class very briefly. So if anyone remembers that, I can type like echo hello. The same thing. So like similarly, I can run that. It'll sort of print it out there. Cool, that works. Sweet. So you can see here that all these commands sort of, you can invoke them like on their own. They don't, you can sort of like run them just like they're a program, like just a file on your computer, and you can sort of run that file and it'll do the thing, and that's cool. But let me show you where node is. So the reason why that was a half lie is because there's actually multiple bin directories. The one at the root is it's the one where all these system level binaries live. So let's go back to that sort of thing where you have like the data center or the mainframe. Let's say you've got this mainframe with lots of different users on it, and you want to give certain programs access, like some people access to every program, and you want to give some people only access to other programs. So every directory in /bin is accessible to everybody. Like that's just like it's there. You got it. Like you log in, you got it. But there are other things where like you may want to give certain directories, certain things accessible, certain users accessibility to certain programs only. And where that comes in is in the user directory. So if I go into the user directory, I do ls, you'll see there's some things in here that like kind of look similar to what was in the / directory. Like there's a user bin, there's like a user s bin. Okay. There's some other stuff in here too. What's going on there? Well, so it turns out that the way that this sort of structure tends to work in the root file system, there are certain sort of phrases that mean things that get reused a lot. So user bin is the directory where all of historically the user binaries have lived. So like binaries, so like in /bin is like all the binaries that are like system level binaries. Like you saw in there, things that are really critical. Like all these commands generally, like you basically can't use the system without them. Like you saw like ls, cd, pwd. Is pwd in here? It's probably in here. Yeah, it's in there. But like all these commands, you can't like use your terminal without them. So really everyone kind of needs them. Like if you don't have them, you're kind of just stuck and you can't do anything. And it's like, okay, well, I guess I'm logging out now. But inside of user bin, that's where the user binaries live. And these are sort of binaries that also tend to be given to everybody, but like these are sort of binaries that are like on the system, but aren't on every system. So in user bin, we now have a lot more stuff. And there's going to be a lot of Mac specific tools in here. But I think nodes probably, and if it's not on here, then it's in one other. Wait. LM, okay, it's top of the list. NO, no, it's not in this list. Okay. Well, but you can see there's a lot of commands in here. And a lot of these are like useful, and I would talk about them, but I mean, if anyone had any questions about any particular one, I could, but I don't think you probably do. So I'm going to keep on moving. But this is sort of where all the commands that are like commands that are on this system but not on every system would live. But there's another thing too. Now, all these commands tend to be installed like kind of like globally by like a tool that will like install them for you. So you can be like, insert tool name here, install my package, and it'll sort of install it for you and set it up and stick it into user bin. That's usually roughly what happens. But again, it's a bit of an oversimplification, and practice is a lot more complicated than that. There's another directory though, which is where if you install a package yourself outside of the package manager, usually where it goes. And that is user local bin. And you'll notice there's actually a lot of copies of the same commands in both, and there's a good reason why that is. And I'm pretty sure node's probably in here. If it isn't in here, then I'm going to have to check because I'm not actually sure where it is. Yeah, where is it? Oh gosh, yeah, because I've got it installed in a weird way. Okay, node should be in this list. And ls should probably find node bin, user bin, or user local bin. And user local bin, like these are sort of things that I've like compiled these and installed these myself on my computer. Okay. Well, that wasn't quite as educational as I thought I was going to be, but whatever. Hopefully you got something out of that. One last thing I do want to talk about though before we keep moving forward, which is this concept of what's called a path. So you remember how briefly, was this at OpenHack or was this last week in class? So I was mentioning to somebody that like the terminal, the shell, the application you're running in the terminal is kind of like a programming language. You can do a lot of interesting things in it that are programming language-y. And one of them is you can define variables. And in fact, in your terminal, there's a lot of variables defined by default. If you want to see them all, there's a command you can run called env. It'll print them all out for you. And one of the most important ones, you'll see actually the longest one, I think, in my mind here, is a variable called path, P-A-T-H, all uppercase. And what this variable does, you'll see it has a bunch of sort of file paths in here, and they're all colon separated. So file path, colon, file path, colon, file path, colon. And if we go through here, you'll see, okay, starting at this point, user local bin, colon, user bin, colon, bin, user sbin, like there's all these sort of directories that sort of look similar to what we talked about. I should also mention sbin real quick. Like sbin stands for super user binary. It's where all the binaries that sort of require a root user exist. We'll talk about maybe that shortly if people care about it, but think of it as just another kind of bin folder. It's another sort of like designation. So you have all these, and what the path does, it's the environment, a variable that the shell will use, so the shell being the sort of the thing running in your terminal here, to figure out where to find your command. So if I, let's say, type like, what's an example of a command that was in here? Oh, I think less was one. Yeah, cool. So, okay, I guess I got to introduce a new command here if we're going to do this, because I didn't show you this. This is not planned. I'm making lots of mistakes, but it's cool, and we're learning, I think, so it's fine. Remember how I talked about cat, how you can use that to print out files? Well, there's another command. Actually, no, I got a better one. Yeah, perfect. We talked about man before, right? This is sort of manual pages for like curl. That one we can use because you've heard of that one. So man is a command that you can use to see those manual pages. But it's also defined somewhere on the file system somewhere. And if I go up here, go to the path, when I run ban, what it's going to do is it's going to look in each of these directories. And it's going to look for something called man, like a file called man. And if that exists, it'll run it, and that's your command. So let's sort of do what the shell does here manually. So I'm going to take this directory here, this first one in my path, and I'm going to go to it, C to it. I'm going to run ls. I'm going to look in here. I don't see anything called man in this directory. Okay, cool. That's the first one down. Okay, next one. This one. Go to there. ls. Okay. Nothing called man in here. This is where my node is, by the way, in this directory. So this is sort of where it would stop if I were using node. It would sort of go here and be like, oh, cool, that's where node is. Okay, move forward. Good to go. Okay, but it isn't there. Go here. Oh, that one doesn't exist. So I guess there's a part of my path that just doesn't exist. So it just skips over that. I should probably remove that. Okay. And it looks like that also doesn't exist. Cool. And my path is nice and updated. Okay. User local bin. Oh, oops. First user local bin. Okay.
Why do you have so many paths again? I'm looking at mine and I got like one path.
Yeah, it's because I've got a lot of software installed on this computer and a lot of software that I've installed in particular ways. So a thing that sometimes software will do when you install is instead of putting itself in the regular path, it'll put itself into its own. That has its own. One nice thing is it makes your one spot. And you also probably noticed that all those directories I had all were like a directory / bin. So it's like a binary with the directory within their directory. So it's like still kind of keeping the sort of like the pattern up, but it's just like they want to make their own specific bin directory within there. So in my case, I installed Node with a tool called NVM, which likes to put itself into its own like bin directory. I think I installed Python in a fancy way because they wanted me to do that at work, a fancy way. But yeah, so that's why it is. And yeah, you're probably gonna have much less because you probably have less installed in your computer.
Yeah, I just got like Homebrew. That's about it.
Fair enough. Yeah, Homebrew will actually, I think. Well, let me check. No, I guess Homebrew puts it in the right spot. That's good. But I can sort of keep doing ls, going through one by one in advance. It's in using. Oh gosh, it's the other side. Is it? Oh, come on. Yeah, it's there somewhere. Wow, these demos are not so great. I promise this stuff actually works. Yeah, there it is, man, right there. So yeah, that's sort of how the terminal knows what to run. And understanding this concept is kind of cool because you'll also notice that the way it works is kind of not dissimilar to the way file systems work. Where sort of like you can have things that override things. Like if user local bin exists, in my case, that's not actually going to ever. It's not ever going to get run because, like in my case, users Ryan NVM versions node v. This thing is before it, and there's a node in this directory, so that'll always get run. So you can sort of like, and that's why there are certain things that are at the beginning of the path before all the main stuff, and at the end of the path, like custom things, because some things I want to sort of prefer the system version, and some things I want to prefer my version. So if I want to prefer my version, I put it at the beginning of the path. If I want to prefer the system version, I put it at the end of the path. So anyway, that's probably way more about path than most people care to know, but hopefully that was cool. And there's a lot of sort of kind of that path concept is something you run into pretty often in Unix. There's other kinds of paths. This is sort of the path, but there are like other cases where you might use a path, this sort of concept to sort of specify like a series of directories to search for a thing. Yeah.
So remember when you're trying to access those paths and it didn't work? Why was
Mhm.
that?
Access those paths and it didn't work.
Yeah, you're like, you need to go back and update them or something.
Oh, because it didn't work because I have, so I think to be clear, when I was saying didn't work, like I was looking for binaries in directories where they didn't exist because they were in different places or different directories that were earlier on in my path. So like I was looking for like node in user local bin or user bin. And
Oh, so
node
it was in the wrong spot?
yeah, I was in the wrong
Okay.
spot, but that was okay because it was in a different location. It's a non-standard location that's at the beginning of my path. So because it's in my path, it's going to search that location. It's just this is not going to be in everybody's path. It's in my path because I've set that up on my system in a specific way.
Gotcha.
And there's a way you can configure your path. So, and this is like a user level setting. So a common thing people will actually do is they'll make a bin directory in their home folder. And they can put all their binaries, all their applications in that bin directory. And they'll add that to their path. And then those are sort of binaries they have access to that other people don't. So you can sort of see how this concept kind of extends in a lot of different ways. You sort of make a directory in sort of the place you think it makes logically the most sense. And then you stick a directory in there and you put all your binaries. Usually in directory you make that like contains the bin directory, you'll put other things related to that application, like maybe it's source code. So I don't know. It's a pattern that's been used a lot in Unix and tends to be followed in a lot of places. So that's bin. Let's talk about sbin. So in sbin, there's some other things, and these are sort of other applications here. These are applications that require super user privileges to run. What's super user? What's that? So maybe you've heard of this concept of a root user, or if you maybe have like an Android phone, you've heard the term like rooting the Android phone or something like that. So when you log into a Unix system, you log in with a specific user account. And that user account is just like sort of you expect on a computer. It's usually associated one-to-one with like a person who actually uses that computer. However, in Unix, there's actually more user accounts than just users on the system. It's a command you can run, I believe, called users. I thought it was users. Users all. Oh. Is it that? No. Okay. Well, I forget what it is. But there's a command you can run which will list all the users in the system. And if I do that, you'd see there's actually quite a few users. Probably on the order of like 20 users on this computer. Each of those users, though, sort of has a specific purpose. One of them is the user of Ryan, me. And if you run actually who am I in the shell, it'll print out your own username. So I'm Ryan on this computer. There's a lot of other users. The most important other user to know about, though, is a user called root, R-O-O-T. So in general, on Unix systems, the user named root can do everything. Individual users, like Ryan or your user account on your system, if you run who am I in your terminal, you'll probably see something similar where you'll get like a user like this. Can't do everything. You can only do sort of a subset of things. And this is kind of by design and a really important principle in Unix. So on Unix systems, one of the most important things is they have what's called a permission model. A model where like users by default cannot do things unless they are given permission to do things. So a great example of this is like, let's say I want to create a new directory in the root of the file system. Like I want to make like /Ryan. I can try to do that, but I'm not going to have permission to do that. Like, because you think about it, you're back on these old mainframes. You don't just want people making random directories in the root of the file system. Like that's going to be like, be annoying. It's going to make like garbage stuff people have to clean up later. You want to lock that down. You want to make it so people can't just do that. So for that, this is like one of the benefits to this model that Unix provides. Now, on the other hand, Windows, the model, is allow everything unless you specifically do not allow you to do something. So like you can think of it as Unix being like a whitelist and Windows being like a blacklist, or sort of like an allow list and a block list, or sort of those sort of terminologies. And it's like there are pros and cons to both, which I'm already way down a rabbit hole here, but like that's a thing that there are reasons why that is good and bad in certain circumstances. But why this is important is there are some things that only the root user or only users with higher privileges can do. And sometimes you need to do those things. Like, let's say I wanted to do one of these like tasks, like make a directory in my root file system in slash, like I need to somehow like be root to do that. So there's a command you've probably run into. I mean, we used it at least once last week and I sort of hand waved over it and didn't actually tell you what it did, called sudo. Cool. Have a good night. The sudo command stands for super user do. And it means super user, another word for the root user, do this thing as the super user, as the root user. And it's a command you can run that takes as a parameter another command. So this command, you can sort of run it with like your regular user. And it will then, on your behalf, if you sort of have the correct permission set up, will run this command as a root user. So a great example, remember earlier this week, we tried to run netcat. And we wanted to listen on a port that was less than 1,000. Is that only root users can do. So if I try to do like nc-l80, oh, that's going to work for me. Well, okay. Well, that's my examples are not working today. I'm sorry. But like that's a thing where like you would normally get a permissions issue if you tried to do that. But if you ran that with sudo, like sudo nc-l80. So what to like really understand what's going on here, like think of this as like you're running the command sudo and you're passing it this as a parameter. And then behind the scenes, sudo then is then running this inside of the code of sudo with this parameter and this parameter. So like you're putting sudo on the front, but that's actually what's going on behind the scenes. It's sort of like this is like the parameter being passed to sudo. But anyway, you could now run this with sudo and it would ask you for your password. And sort of this is what you do to like sort of give it the permission to run that thing as root. So I type that in and then sort of it'll run it as root. But why this is important is because all these binaries in SBIN are binaries that need to have root privileges to at least do something. Unfortunately, we haven't talked about any of these.
Is
But-
HTOP in there?
It is not.
That's like my favorite one.
Yeah. I don't know if do I have HTOP installed? I do have HTOP installed. Nice. Oh, I should also mention this command which, I've used it a few times. This command, if you give it a binary or a command name, it'll tell you where it's going to do the path search for you and tell you where it's to find it. So HTOP's located in user local bin, it looks like, for me. Yeah, so it's just a bin, it's not an SBIN. It looks like it doesn't need root privileges, but maybe.
Wait, go over the difference between bin and SBIN again.
So bin, the commands in bin are just sort of regular binaries or commands. The commands in SBIN are commands that at least sometimes will need root privileges to run.
Gotcha.
I
So
believe.
one will need the password and the other you can just access willy-nilly.
Yeah. Now note, it doesn't mean you always have to run these commands with sudo in front of them. It just means that in some certain structures of those commands, they need root privileges.
Understood.
Cool. Actually, ifconfig's in here. There we go. That's one we talked about. So ifconfig, in certain sort of ways you can use it, will actually do things that are privileged things. I think like what ifconfig also can manage like adding and removing network interfaces, and that's a privileged task. So we just used it to list them, but you can also do like updating them with it. So I think that's why it's in there, if I remember right. Yeah, so that's kind of the difference there. In practice, at the level you all are at, it's not all that important. Like they're kind of going to be interchangeable, but like, yeah, cool to know, I guess. It's there.
Mm.
Um, let's see, what other directories can I talk about that would be helpful? Temp. Ooh, this is a really helpful one. So temp is a directory that is what's called a RAM file system, a RAMFS. So temp isn't actually a real hard drive. Like it's not actually on that. It's a sort of like a virtual directory that exists in RAM on your system's memory. So if I put something in the temp directory, like if I put a file in there and I reboot my computer, it'll be gone when I start it back up again. And temp, like the way that works behind the scenes is like there's a section of your RAM, your sort of system memory, that's sort of been allocated for temp. And that's sort of like any file you put in temp will actually end up there. So there's like a way you can sort of mount, like Unix has all these crazy ways you can mount things in your file system. And one of the things you can do is you can mount bits of RAM, like mount bits of memory in your file system. And that's at least historically how a temp FS might work. There's other ways you can do it too, but like that's probably the easiest way to explain. And the way that, at least when I've done this stuff, I've set it up that way.
And what would be the benefit to mounting RAM and all of that stuff in your file system?
Yeah, good question. So the biggest benefit is, let's say you need to make a file that's just a temporary file for your program to run. Something like maybe you need to like write some user input to the file system or something. This is maybe kind of a contrived example, but there are certain situations where you need to write files, but you just kind of need them to exist temporarily. And the tempfs is sort of the classical place where those would go. So take a look. So I have recently was running AutoCAD on this computer. So there's a bunch of stuff that looks like Autodesk puts in here. There's also some stuff that I think Chrome puts in here as well. And I'm using a program called Tmux right now, and it looks like Tmux sticks a thing in there. But all the files in temp should just be assumed to be temporary, and if you lose them, they shouldn't be like critical files.
So, do you know that I forgot what the proper term is, but like something about garbage collecting in JavaScript, where it's like it throws away code that takes up too much space when it's not needed. That's kind of what it reminds me of with this temp thing.
Yeah, exactly. But imagine that garbage collector thing runs when you reboot your computer too.
Okay.
So like when you restart your computer, this directory will be empty, with the caveat that when you check, some applications might have started that wrote to it already. So like when you look at it, it may not be empty, but like when the computer starts up, there's a period in time at which it is empty before stuff starts writing to it. If you make a file and you reboot, it won't be there anymore as well. So like, I guess that's also the big caveat I should say. Like, if you write a thing to temp, like it should not be an important file and it's going to go away. So like, don't put important stuff there. Let's see, what else we have not talked about? etc. Ah, yes. So the etc directory, this is just so bad to say, but it's like the directory where everything else goes, etc. Like, yeah, it's where everything else goes. It's like kind of, so there's a lot of stuff in here. Historically, though, there's some like important files in here. This is where a lot of configuration files will go. So let's say I have like a program running on my computer, and I've got a file that I want to make to sort of set it up to run in a certain way. I'm trying to think if you've in the DevOps module, if you had to deal with this, but probably not. Or like if you've dug into VS Code at all, VS Code has a configuration file you can edit to sort of change how the application works and runs. And I don't think theirs is an etc, but it's the kind of thing that would be here. And a lot of these files will end in conf, which is sort of configuration, is what that means. Also, like ini is sort of a popular file format for configurations, and some of them just won't have suffixes. That's the other thing. In Unix, like files don't have to have extensions. In Windows, you tend to usually have extensions. So like a file called ls is not weird. Like that's totally fine on Unix, but on Windows, that would be maybe a little more unusual. But yeah, like another common, actually, here we go. Here's a good one. We talk about DNS. So a thing we didn't talk about with DNS, one of those little details I skipped over is DNS actually, there's a step on DNS that happens locally on your computer where sort of your computer will look at a configuration file that to sort of have like its own little mapping from like domain name to IP. Like that sort of is a thing that happens locally for that. That's sort of like a first step before it even talks to anything online, like before it looks up online, like what domain maps to what IP address. And that configuration file to make that happen is called resolve.conf and lives in etc. So let's cat that out. And what you'll see in here is mine actually is remarkably small. Interesting. Interesting. So at the top of this file, there's a macOS notice with comments. So in a lot of these files, the pound sign is a comment. So it's like / in JavaScript, but it says, this file is not consulted for DNS hostname resolution. So I guess on Macs, etc resolve.conf isn't actually used for some reason. But historically, this is sort of what would be used for this first step of like DNS resolution. And what this means is like every entry in here sort of maps to another thing. So like if I did something like I went to like http://name server, then what that would do behind the scenes is make a request to this IP address on port 80. And what's cool about this is you can add entries to here behind the scenes to like add your own custom DNS entries. So maybe you have like, but it's just a nice, you can add your own entry in here and then just sort of be able to like now everywhere on the system like has that DNS entry just working like that. It's kind of cool. This is like in practice, this is something you do very often. No, it isn't. But in some systems, that localhost entry is actually defined in here. And I was kind of hoping that would be, but it looks like on Macs it isn't. But there would be like localhost space 127.0.0.1. And that's where that actual thing is often defined in this etc resolve.conf file. Yeah, but there's just lots of configuration files in here. And that tends to be a lot of what's in here. Yeah, I mean, I think that's most of the really important stuff. There's some less important stuff I could talk about, but I think I've probably saturated most of you, and I don't want to go too much over your head here. So I can keep talking, but like, also we're like 45 minutes over and stuff, and like you probably all want to eat dinner. So
For me, thing is just a matter of using it enough so I can actually remember this and get to the flow.
makes sense. Actually, I'll leave you with one resource, this thing called the Unix jargon file. I think that's what it's called. Oh, come on. It's not gonna like, here we go. Yeah. Is this like an HTML version of it? What the heck is this? Oh yeah, it's like, okay. So this thing is like a thing known as sort of like Unix circles. It was written in, I don't know when, a very long time ago. Yeah, like in the mid 70s is sort of where it started. And this sort of is like the background of a lot of the stuff. It's sort of like set out a lot of sort of the very early standards and approaches to like how Unix tends to work. And I'm trying to find it. I'm kind of surprised it's not like, okay, maybe this is what I want. Yeah. Yeah, so this sort of thing. And it just has like a lot of sort of like text, like phrases and sort of history in it. And I'm not saying you should go read this. This would not be probably good weekend reading or something like that, given where you all are. But I would say though, if you are curious about why Unix does a certain thing a certain way, this is a great place to like try to figure it out and sort of like search through it and read a little bit, like snippets from this. This talks about like the way I learned about all this sort of stuff we just talked about around the file system is that I've read some of this and read some books and sort of resources that refer to this. So like someone came up with all this in like the 70s, and then that sort of evolved through oral tradition and sort of like code tradition until someone was like, I should write all this down, and wrote the jargon file. So this is sort of the closest written record to like all these decisions that probably exists out there.
Pretty much documentation, huh?
Yeah, documentation.
The doc.
And like some of it's like like old, like weird social stuff too. Like verb doubling. A standard construction is to double a verb and use it as a comment on what the implied subject does. Like this is just like I expect like to have like techno music and like in the 80s when I'm reading this stuff. It's like weird. It's like you don't use this is not like part of modern like hacker culture, but it was back then. Yeah. Okay, yeah, I just whatever. I'm winitude, disgustitude, hackification. Okay, whatever. It gets like weird. And
I don't
it's
even know
not
what that means.
yeah, like I don't either. But like it's like I would say like think of this more as like a historical document from like a point in time. And it's just like fascinating to read from that perspective. But like
Mhm.
how relevant is it to careers in code? Just about zero.
Mm.
Let me just put that out there. Like this is more just me being like, if you're really curious about this stuff, I want to do some self-research. This would be a great place to start. But don't take this as like you need to, this is not like homework you need to read about or anything like that. No, this is like if you think this stuff is interesting and want to know more. Like if
Gotcha.
I were to search like bin in here, or like user. Yeah. And also like define things like nuke to unintentionally delete the entire content of a given directory or storage volume. On Linux, RMR user will nuke everything in the user file system, never used for accidental deletion. The opposite is blow away. I've used that one on occasion. Yeah, whatever. So look that up if you're curious. And there's like different versions of it because this thing's evolved for so many years. And like someone like found all this on like a tape somewhere, like a magnetic tape that was like, that was how you'd like back in the day, you didn't have lots of like hard drive space. So you'd store things on like magnetic media. And like there's all this stuff around like tape storage in Unix that like it comes up all over the place. And there's all these decisions that were made because like, oh, we're going to store it in this way because it makes accessing it on tapes faster. It's like, yeah, great. I don't care. Whatever. Okay. I think I'm about done here. I'm getting a little loopy. I need to eat some food. But thanks, folks. That was a lot of fun. Looking forward to
Information
seeing y'all.
overload for me.
Yeah, but this is recorded, so you can watch it again if you want. And just want to also say, like, I realized that the fetch thing at the very end of the class last time was probably a little overwhelming. Maybe not, but for some folks it was a little bit. So we're gonna go all through that again tomorrow. So like, tomorrow is the real fetch day. Yesterday or Thursday, or I guess it was Wednesday, was just the preview. So cool.
All right. See you. Ryan.
Sweet. See you tomorrow. Bye.
Right.